In this lesson, we're going to tackle two properties of trig graphs. The first is something we've already touched on, which is finding the period from a given equation. So you remember from your previous work here that these are called periodic functions sometimes, and the period is the distance for one full sort of rotation. So you can think of it as one full trip around the unit circle or one full repetition of the pattern here. So I like to look at it from peak to peak. And your standard, so if this is f of x equals sine of x, your standard period here is 2 pi, because 2 pi is 360 degrees all the way around the unit circle. But we can stretch this curve out or compress it, as we've seen in previous lessons. So what we know, right, is that if I have f of x equals sine b to the x, and I just pick capital B because that's the variable that delta math uses, it doesn't really matter what you put there. That parameter b, though, controls the period of the graph, right? So that is the number that will change as we stretch out the graph or compress it, right? And the relationship, right, is that the period of the graph is equal to 2 pi divided by b. We saw this in the previous lesson. So that makes it very easy to figure out the period of a given function. So I'll show you an example or two. So here we have a function, and I intentionally picked one that looks kind of crazy to show you that it doesn't actually matter, right? So there's actually 4 different parameters in this function. We have, our amplitude, our midline, and then we have this new thing in there. This 5 pi over 6 is called a phase shift. It actually shifts the curves, or like the peaks or the troughs, I guess you could say, left or right. We're not going to worry about any of that, though. We're just going to worry about what is in front of the x, because that is like my b value in our model here. So in this case, I'm going to do my period for this function is going to be 2 pi divided by 4 over 7. And this is, we're divided by a fraction, right? So we're going to take the reciprocal. So we're going to say 2 pi instead times 7 over 4. And then we get, remember it's 2 pi over 1. So 14 pi, and multiply the top, over multiply the bottoms. So that is the period of this function, and we could reduce it, I guess we should, right? 7 pi over 2. Okay, so that's all we're doing. I'll do one more example, but I think you probably got it. One that looks kind of deceptively simple. And again, we're going to pay attention to that number in front of the x. Okay, here, don't be tempted to just pick 3. I've seen students be tempted to do that before, right? This is really, x over 3 is the same as 1/3 x. So my b here is 1 over 3. Okay, so my period is going to be same as before. 2 pi over 1 over 3, and I'm dividing by a fraction, so I'm going to multiply by reciprocal, equals 2 pi over 1 times 3 over 1, and then we get, obviously, 6 pi is the period here, right? So dividing this x by 3 actually stretches out that graph 3 times longer, right? Because 6 pi is 3 times 2 pi. So I think you'll have an easy time with these. That's all there is to it.